And this question it is given that a particle of mass 10 gram is kept on the surface of a uniform sphere of mass 100 kilogram and radius 10 centimeter. Find the work done against gravitational force between them to take the particle away from sphere. So this question is related to the concept of escape velocity. So once again just read the question so you'll understand it. A particle is kept on the surface of a sphere and the mass of sphere is given and radius is given. Find the work done against gravitational force between them to take the particle away from the sphere. So Rm is to take it away from the gravitational influence. So Rm is to find out how much work we have to done. So we need to supply some amount of energy. So assume that I'm just supplying an energy E to that so that we'll be able to take it away from the gravitational force exerted by the mass. So the concept is related to escape velocity. So I think you might be remembering that the condition for escape velocity or taking an object away from it is we need to keep its total energy as 0. So now it is having a potential energy of minus gmm divided by r, and it was at rest, so it doesn't have any kinetic energy. Now assume that I am just supplying an energy E to this so that we can make its total energy is equal to 0. So we can write the value of energy we need to supply should be equal to plus gmm divided by r, or just identify what about the value of total energy. So if you are supplying that much and total energy in case of gravitation, that total energy will be negative. So if you are supplying that much positive energy, then we can take that object from the surface. It is same as like an atomic structure. You learn that if an electron is having an energy of minus 13.6, then we need to supply plus 13.6 to take it out. You might be studied in the form of ionization potential. Same thing over here. We need to supply positive energy of g mm by r to keep it total energy as 0. So we are supplying energy by doing work on it. So the value of work done should be equal to the energy that we need to supply, that is equal to g mm divided by r. Now we can calculate it. We know that the value of g is 6.67 into 10 raised to minus 11. The value of m is sphere of mass m, which is given as 100 kilogram, into the particle of mass 10 gram, which we can get as 10 into 10 raised to minus 3 because we need to convert it into kilogram, divided by the value of radius. Radius of sphere it is given as 10 centimeter. So we can take it as 10 into 10 raised to minus 2 to convert it into meter. So this is going to give the value of energy, which is equal to